Hi, I'm Debbie Hellman, and it's great to be here. And together with my co-author, Katie Creel, we're going to present our paper, The Algorithmic Leviathan. We submitted this paper through the non-archival track, so you may want to read the actual paper from our SSRN page, and the link is on the slide there. Also, you can see that link at the end of the slide presentation as well. Okay, so why do we call the paper the Algorithmic Leviathan? Well, Hobbes's Leviathan is extremely powerful in the sense that he exercises power in a systemic way over all the subjects in the territory, and also he has arbitrary power. The use of his power need not be predictable, rule-bound, or for a reason. So we're interested in the question, is algorithmic decision-making is automated decision-making, an algorithmic Leviathan? Well, on the one hand, it's pretty systemic. That is, it's used, one algorithm can be used across an entire domain, replacing many human deciders, and it might be arbitrary. We'll be exploring that. We're going to make two claims in the paper, one negative and one positive. The negative claim is that arbitrariness in algorithmic decision-making is not of moral concern, and the positive claim is that arbitrariness becomes problematic when consistently applied at scale. So let me give you a sense of the kind of context we have in mind. We're imagining a hiring manager with thousands of resumes to consider, and the hiring manager has time constraints, information constraints, privacy constraints, and needs to sort through all those resumes and figure out who to interview and then ultimately who to hire. The context that we have in mind, we focus on hiring and lending in the paper to have concrete examples to discuss, but we think what we have to say about arbitrariness and systematicity is generalizable to other contexts as well. So one thing to note about the replacing of many human deciders by one algorithm is that this leads to standardization. Each of the hiring managers may have been deciding according to different criteria, some good, some bad, some arbitrary, but when you replace those 16 people or however many you have with one algorithm, you get standardization. Okay, the outline of the talk. The first part is, does arbitrariness wrong individuals? I'll be doing that part, then I'll turn it over to Katie, and she'll discuss the question, does arbitrariness at scale wrong individuals? Who is arbitrarily excluded, and technical solutions. So first, do arbitrary decisions wrong individuals? Well, in order to answer that question, we've got to get a better grasp on what exactly the claim is when you say the automated decision was arbitrary. What is it that a person is asserting in such a context? And once we figure out what that person is asserting, then we're going to examine the question whether that, whatever we figure out it is morally problematic. So first, we might think that arbitrariness is reducible to the idea of unpredictability, that what you're asserting is the decision is unpredictable. Well, individuals certainly have an interest in predictability so that they can plan and more effectively achieve their ends. And sometimes, in some contexts, they will have an entitlement to a kind of predictability, and that can be because the employer or the lender made a kind of promise or invited a sort of reliance or a detrimental reliance. And in such a context, we do think there is an entitlement. But absent promise or reliance or a special reason of that kind, we don't think there is an entitlement by the prospective employee or borrower to predictability. And the reason is, why would we think that the lender or the employer can't change her goals or her aims or what she wants to do? What gives the prospective employee or borrower a right or an entitlement to that predictability? What about arbitrariness as a lack of constraint by rules? Well, this sense of arbitrariness is unlikely to be engaged in the algorithmic context because algorithms, after all, are rule-bound. They're instantiating rules. Okay. What about a third idea? That is, when you act arbitrarily, you act without a good reason. So what someone's asserting when they assert that an automated decision is arbitrary is that it lacks a good reason. Well, that sounds more promising for sure, but it also invites more inquiry. That is, what kinds of decisions are good such that they would render the decision non-arbitrary? And here we look at three possibilities, three degrees of demandingness of the reason, if you will. First, perhaps it has to be a public-oriented reason. So I say to the prospective borrower, yeah, you didn't get the loan, but that's because if we gave loans to people with your credentials, that would be bad for everybody. Well, that's awfully demanding. That is, why would we think that in order for a lender to act non-arbitrarily in a way that has moral force, it has to act for a public-oriented reason? What about the idea instead that in order to act non-arbitrarily, the employer or lender has to act for a reason that benefits the applicant? Again, that seems overly demanding also. Why do we think that the employer or the lender has an obligation to do things to act for a reason that's good for the applicant in order to be non-arbitrary? That too seems overly demanding. We arrive at our third sense, which we think really gets to the heart of what people are complaining about when they say that a decision is arbitrary. That is, that it doesn't even serve the lender or the employer's own interests. That is, that it's acting according to procedures that are not instrumentally rational. Now, surely an employer or a lender has a reason, its own self-interest, to try to act in ways that are instrumentally rational. But it's a strange moral claim to assert that if the employer or lender doesn't serve its own interests, it has wronged the applicant. We say it's strange to morally require that the employer or the lender act for its own interests. Well, maybe instead we should think about the principle that the claim that one of arbitrariness as a failure to comply with the treat likes alike principle, that at the least the employer or the lender should treat like cases alike. Well, the first thing to note about this principle is that it often actually can require something that a violation of instrumental rationality. If the algorithm has, in the first instance, mischaracterized one applicant, call her Jane, and here comes Joe, and Joe is relevantly like Jane, the treat likes alike principle would require that the algorithm similarly mischaracterize Joe. So interesting to note that if that's how we should interpret the treat likes alike principle, as that requiring that kind of consistency. If it doesn't require that, if it instead speaks to the content of the algorithm, it just reduces to the idea that a requirement of instrumental rationality, which we already examined and rejected as a strange moral assertion. For more on that argument, you may want to check out the paper. Lastly, one might be wondering, in rejecting arbitrariness as of moral concern, are we saying that there aren't bad reasons that on the basis of which these sorts of decisions can be made? And we are not. Surely there are bad reasons if the decider makes a decision on the basis of racism, sexism, what have you. Those are bad reasons. We're just rejecting arbitrariness. That said, a prohibition on arbitrariness can sometimes be useful in screening out bad reasons. That's often how you see it used in the law, for example. But importantly, the moral problem in such case is the bad reason, not the arbitrariness. The arbitrariness is just useful in getting rid of the bad reason. So that leads us to our conclusion. The negative one, as I said, individuals are not entitled to non-arbitrary decisions unless another right specifically guarantees it.
So let's start from this idea that arbitrary decisions may not harm individuals intrinsically, but what happens if they're scaled? Does arbitrariness at scale wrong individuals? So we know that individual companies might have internal hierarchies or rankings, but typically the same hierarchy doesn't consistently dominate. And we think of this as a good thing because if the same hierarchy is used across a sector or geographic territory, it can monopolize access to opportunities. and exclusion of the same people over and over can lead to social hierarchy. So this is a theme from Elizabeth Anderson. We could also think about it, following Joseph Rez, as a question of autonomy. So if autonomy involves access to a sufficient range of varied alternatives, then it's not a moral harm to be denied one alternative or opportunity, such as a job or a loan, but it becomes a threshold harm to autonomy to be shut out of a significant number of possible alternatives. So the harm of exclusion from opportunities is of greater moral importance at scale. So there are many ways to characterize this moral problem with exclusion from opportunities. We could follow Amartya Sen and say that it limits the development of capacities, or we could follow Rawls and say it causes the excluded to become among the least well-off in ways that require remediation. But the key here is that the systematicity is the problem, not the arbitrariness. And the arbitrariness only comes in, we argue, when a significant limit on opportunity lacks even instrumental rationality because of its arbitrariness. This adds to the sense in which it's unjustified. So our second conclusion is that arbitrariness is only of moral concern when arbitrary judgments about the same individuals are uniformly enforced at scale. So now let's think about this arbitrariness and its nature. So in the case of hiring, imagine the very common algorithmic decision-making for resume screening. So here's my resume. We've seen cases in the past in which a correlation between a feature and rejection of candidates seem to be an instance of bias. For example, if you submit two similar resumes, one with a name that's typically coded as female and the other one with a name that's typically coded as male, and the automated decision-making system evaluates those resumes differently, that might be a case of bias. But what about a correlation between a feature that seems arbitrary and acceptance or rejection of candidates? So perhaps just having double majored, or even more arbitrary, having a line of a certain length, a certain distance down your resume. So these seemingly arbitrary features of a candidate's file might be correlated in the original training data with predictive power. And the model's overfitting to the original training data can cause arbitrariness. So let's look at a classic example of what this might look like. Imagine you were trying to train a classifier to separate the red and the blue dots. And the kind of generalizable rule that you wanted looked something like the black line. But let's say your model learned too much, and your model instead learned the green line. So we might say in that case that some of the excessive wiggling or the inclusions into the green, of the green line into the blue or red space might be arbitrary features that this model has now learned. So when is this arbitrariness likely to be scaled up? Well, the easy case is when the same algorithm made by the same company becomes used across a wide sector. So in that case, it's easy to see why the same people would be consistently rejected. But a slightly more complicated case is when the same data set leads to similar artifacts in different algorithms just in virtue of being publicly available and therefore the data set that everyone trains on. So interestingly, sharing training data across models can systematize arbitrariness so that many models made by different entities end up sharing the same arbitrary features. So we might ask the question, who is the algorithmic Job? Who is the person likely to be excluded by this regime? So the first thing to say is that it could be anyone. So arbitrary features are correlated with bad employees, let's say in the original limited training data set, and then a new employee has some characteristic that fits in with that arbitrary feature, they might be rejected just in virtue of that match. So these arbitrary groups might have little in common beyond being the people re-identified by the algorithm or group of algorithms. But it also might not be an arbitrary group. So let's briefly consider the case in which systemic arbitrariness has a disparate impact on a protected group. So this is very important, but the thing we want to say here is that the decision making is discriminatory, and this is a separate concern from the arbitrariness. So we already have a good way to talk about why that case is problematic. So let's focus on a related case, which is subgroup analysis. So if we want to find out if our algorithm is discriminatory or biased against a certain group, we might do an audit to figure this out. And audits often only focus on federally protected categories, like race, sex, age. But this arbitrary exclusion might in fact correlate with a subgroup or an intersectional category within more than one axis of existing discrimination. And these audits for single axis discrimination will miss it. Legal standards don't require audits for multi-axis discrimination. So it can be very difficult, both technically and practically, to audit for arbitrary bias against tiny subgroups, and basically impossible to audit for bias against individuals. So the key takeaway here is that any individual could be arbitrarily excluded by the algorithmic Leviathan, or the groups could be subgroups or protected categories, and either way, these individuals will be hard to find using existing auditing techniques. So let's think about what we can do about this. Our proposal is that we fight arbitrariness with randomness. So let's say you did something like a random classifier ensemble. You would take your original training data set and then train multiple models of different kinds, or the same kind of model trained on different subsets of that data set. And the goal would be to constrain the models to be as diverse as possible in their token outcomes while still retaining your threshold of performance. And what you're relying on here is a known phenomenon called predictive multiplicity, or just multiplicity, which is that you often have multiple different models that have very similar performance but are meaningfully different. And this is often frustrating, but in this case, we're going to take advantage of it. And we're going to say, let's choose randomly among these model predictions. And let's let the stochasticity preserve the possibility of being classified otherwise. So imagine that we have our first model, Model A. We're evaluating 100 candidates. Let's just posit that 10 of them are the most qualified. And Model A finds 9 out of the 10. But it has an arbitrary feature that ends up leading to the rejection of Alice. Now, if all we had was Model A, Alice would be out of luck. But let's say we also have Model B. Now, Model B has equally good performance. It finds 9 out of the 10 of the candidates. But unfortunately, because of a different arbitrary feature, it rejects Juan. Now, if we can randomize between these models, neither Alice nor Juan, nor the other people who might be excluded by different models, will be consistently rejected. So the value of random classifier ensembles is that, first of all, the multiplicity preserves the performance in the task. If we sacrifice some performance, we also know that the domain is noisy and underspecified. But most importantly for our moral case, it decreases the hegemony of false negatives. And this is morally important if the model is used across the sector. So thanks very much for coming to our talk, and please find our paper archived at SSRN.